Alright, now this is 3.11 and 3.12 kind of mixed together as far as the two chapters here. The reason I'm mixing them together is that both of these things cover very similar material. So we want to address them both in the same way. Alright? In this case, it's disubstituted cycloalkanes. So if I've got two methyl cycloalkanes, there's a couple that we're going to see. Okay? The ones that I'm interested in are going to be these two, or these three, excuse me. Alright? The 1, 2, the 1, 3, and the 1, 4. Okay? Now, if I've got a disubstituted cycloalkane, I can have two different isomers that are associated with it. One that is going to be with the two CH3s both up with regards to whatever they're bound to, and one other one that's going to have one up and one down, or one down, one up. You can also have two that are down, but that's basically the same as being up. Okay, so what does that mean? So over here, I can have two different stereoisomers. I can have the one where they're both on the same side, and one where they're both on opposite sides. Now, which one is going to be better? Which one's going to be more stable? Okay? Now, before we identify which one of these is more stable, which one's not, we've got to learn terminology. Okay? If these two CH3s are on the same side, they're sisters. Okay, they're cis to each other. Okay, means on the same side. If they're on opposite sides, they have to take trains to get to each other, or trans. Okay, so this is a trans form. Okay. Now I've got this chair that I've got drawn out from 3.10 still up here on the board, so I want to represent it. And what I'm going to do is I'm going to represent carbon 1 and carbon 2 of the cis form. Okay. So here's carbon 1, okay, so there's 1, and over here I'm going to put 2 in that position. Where is the CH3 going to be? Now, if you notice over here, this CH3 is up with regards to this hydrogen. This hydrogen is up with regards to that H. So in order to have two, or a cis form, both of those have to be in the up position on their particular carbon. So what that means is that for cis, I've got to have that guy, all right? So I've got to have those two CH3s in that position. If I do a chair flip here, the one position is down here, the two positions over here. Now this CH3 moves to the equatorial position, and this H is down. And this CH3 now moves up into the up position, okay, the axial position. Both of these are still up with regards to each other. One's equatorial and one's axial. Over here, this one's axial and this one's equatorial. Which one of these is higher in energy? If you thought neither, you're correct. The reason being is that one's axial and one's equatorial. The other one is axial, one's equatorial. The energy is the same in both of the molecules. So for cis, both of the chair forms are going to be equal, 50-50 in solution. Okay? Now if I change this and go to trans, what ends up happening? Now, I've got a CH3 down here, and over here, I've got a CH3 in this position. Which one of these equilibrium forms is going to be more stable? The one on the top or the one on the bottom? This one has two axial positions. So I have diaxial interactions 1, 2, and then I've also got 3 and 4. Okay? This is a bond right here. So I've got 4 diaxial interactions. So that top one is not very stable at all. This one down here is far more stable. So if I drew the equilibrium arrow, I draw a little one going towards that one and a large one coming down, because this is the one that's going to exist in the greater amount compared to this other one. Okay? So The most stable of these, between all of these, is the transform where they're both equatorial. Okay? Now let's go ahead and look at the next ones. Okay, two wedges versus wedge and dash. Okay, bear in mind, remember, if I've got two wedges, there could also be two dashes as well. But for right now, I'm just going to use dashes. And I'm also going to draw out this one as well. Since we know what we're doing to compare these things, this is what we're going to do to draw them out. Okay? Right, there they all are. Okay, so far so good. Now we want to look at which one of these is more stable. So this is going to be for the 1, 3. I'll draw these things out. The 3 position's over here, and the 3 position's going to be over here. Change these CH3s to hydrogens. Alright, and now I've got this thing, CH3, CH3H. Okay, which one is more stable? The one where they're both equatorial, the one where they're both axial. Alright, in this case, the two cis forms are going to be the ones that are going to be stable, that are going to be the ones that have the one that's not stable and the one that is stable. Alright? This one, not stable. It's got diaxial interactions between two CH3s. That's a serious problem. Okay, energetically that's a big impediment. So as a result, this one doesn't exist very often. This one does. Okay? This is the most stable form. So over here, most stable was the trans, had the one that was most stable here. Over here with this cis one, that's going to be the one that's the most stable, the one where they're both in the equatorial form. Okay, now what about down here with 1, 4? Let's go ahead and draw out 1, 4. Here's the 4 position, here's the 4 position. Okay, wipe out the 3, we're not interested in that. Change this back to a hydrogen. And change this back to a hydrogen. Alright, and if over here I've got a cis position, the cis, I've got two CH3s, and over on this one, I'm going to have a CH3, which is up. Notice that this one's up with regard to the hydrogen, this one's up with regards to the hydrogen. So are both of those equal in energy, or is there a difference in energy there for the two cis forms? In this case, for 1, 4, both of them are going to be equal in energy. Okay? If I do the transform, you'll be able to see it right off the bat. Okay? Trans. You can see how stable this one is. So if you guess what the other chair flip is going to be, it's that both CH3s are going to be in the axial position. And again, that's a problem. So for 1, 4, it's going to be one of the transforms, which is most stable. The trans where they're both in the equatorial position. Alright? Alright. That covers it all.